Okay, example 10, putting together everything we've learned so far. Okay, we have a spring mesh system here, spring and a mesh undergoing oscillation. Comprises a cut of mass 1.5 kg and is performing a simple harmonic motion. Okay, this phrase is important because once we are told that it performs a simple harmonic motion, that means we can use all the equations that we have for simple harmonic motion. Okay, and then we are given that the amplitude is 0.3 meters. So this is the furthest stretch that is undergoing a to and fro oscillation about the equilibrium point. And the leftmost is 0.3 and go to rightmost 0.3 meter. Okay, amplitude is 0.3 meters. And we also given that the period is 2.0 seconds. So from here, go here and come back here, total time 2.0 seconds for one period. Okay, the cut is displaced left and released at time t=0. Okay, this phrase is also important. It tells us that this cut starts at the amplitude position. Okay, because we know that the formula for simple harmonic motion, there's two sets of formula. One set for if it's released at the amplitude position, another set is if it's released, if it's starting, if the motion starts at the equivalent position. Okay, so this one, the motion starts at the extreme end. Okay, take rightwards as positive. That means at this point here, the displacement is minus 0.3 meters because it's on the left side of the equilibrium point. At this point here, the displacement is positive 0.30 meters. Okay, so at the beginning, x is negative 0.30 because it starts here. Okay, then what's the question? Okay, the question is part A, write down an expression. Okay, expression means a formula in terms of some variables. So it's not a number. Okay, it's some formula. A formula for the displacement of the cut. The displacement is x. So they ask us to write down a formula for the x. But this question is a bit vague because we know that there are many formulas for displacement of the cut. Which formula are they looking for? I suppose because the question mentioned at any point in time, I suppose they're asking for a formula for x in terms of t. Okay, it'll be clearer if the question has specified that get expression for displacement in terms of t. Okay, so what we're going to do is we're going to write down, okay, recall what's the formula for x. There are many formulas for x, but what they want is a formula that's in terms of t. Okay, what is the formula for x in terms of t for simple harmonic motion? Well, the formula is just simply x equals to, remember the formula for x is either sine or cosine. Sine if it's starting at the equilibrium point, cosine if it's starting at the amplitude position, it's going to be cosine, but because it starts at negative displacement, so the formula we're going to use is negative, the cosine version. The full version is in front of the cosine is the amplitude, okay, 0.30, and the cosine something t, the something is your 2 pi over period, okay, 2 pi over period, which is actually omega. Okay, this thing is your amplitude. So simplify a bit, we get negative 0.30 cosine pi t, pi being 2 pi over 2. Okay, so this is the formula they're asking for. Okay, this is the formula that starts at negative 0.3 at the beginning, so it's a negative cosine graph, negative cosine expression. Okay, part B. Okay, part B, they want us to again write down, recall the formula. This time they want to recall the formula for acceleration. Again, there are many formulas for acceleration. Suppose they want the formula that's in terms of t. Okay, and then there's a second question within this part B. what is the maximum magnitude of acceleration of a cut? Let's do the first one first. What's the formula for the acceleration in terms of t? Okay, then no problem. What we do is, if we forgot the formula for acceleration, what we can do is we can just differentiate x 2 times, because differentiate x 1 time is the velocity, differentiate another time you get acceleration. So if you differentiate 2 times, you get negative. The pi can bring out, first going to differentiate 2 times, pi bring out 2 times, so it's minus omega x naught square. Okay, so it's negative 0.30 pi square cosine pi t. Okay, so this is the formula for the acceleration. Okay, you can refer to the last page of lecture notes, all the formula for x, v, and t and a. Okay, so this is the formula for a. Okay, but basically we can derive the a by just differentiating this 2 times. Okay, then what's the maximum magnitude of the acceleration? This is a cosine function. We know that anything before the cosine is a maximum value, because maximum value for cosine is 1. So what's the maximum value for a? Is actually we can ignore the minus sign, because magnitude don't need the minus sign. Okay, so a naught is going to be 0.30 pi square without the minus sign here. So the answer is just we work it out. We don't leave our answer in pi. We give our answer in 2 or 3 SF. Okay, in 2 SF is 3.0. Okay, so the maximum magnitude of the acceleration is magnitude must always give a positive value, so it's 3.0 meter per second square. Okay, can you remove this minus sign here? Okay, part C. Okay, what's the part C question? Okay, part C, what is the maximum magnitude of the restoring force? Restoring force is the net force. Part B will just ask us to find the maximum acceleration. So from the maximum acceleration, how do we find the maximum net force? Well, we just use the Newton's second law, F equals to ma. Okay, we use the A from the previous parts, and that will give us the maximum force. Okay, so that's part C. Okay, then part D, what's our part D question? What is the force constant of the spring? Okay, force constant is K. K, we have to use the Hooke's law. Hooke's law is F equals to Kx. Part C, we have just found the maximum force. We know that force is proportional to the extension. Of course, when force is maximum, your x is the maximum. What is the maximum extension? The amplitude. So we use F equals Kx, use the maximum force in part C, we use the maximum extension, which is the amplitude. Okay, we sub in, we get the spring constant K, 15 Newton per meter. And finally, part E, okay, they ask us to sketch graph. They want us to sketch the graph of acceleration against displacement graph. Okay, we know that there's a formula for acceleration in terms of displacement. The formula is okay, if you refer to the last page on summary, there are a lot of formulas for acceleration, for velocity, for time, and so on. Okay. In here, we specifically want the formula for acceleration in terms of displacement. Earlier on, part B, they asked us for acceleration in terms of time. Okay, we don't want that now. We want acceleration in terms of displacement. In A in terms of x. Yes, the formula is A equals to minus omega square x. So it's a straight line graph passing through origin with negative gradient. Okay, so this is the answer. And we have to mark out the values. The amplitude of the maximum displacement is 0.3 and minus 0.3. And then we also mark out the maximum acceleration, which we have calculated early on, 3.0 and minus 3.0. A equals to minus something x. Is a straight line graph, negative gradient passing through origin. Okay, so that's example 10.